Perfect. We are live. We can start with the final jury at the Synthetic Landscape Lab. Maria, would you like to introduce the morning session?
Yes, hello everybody. That's great to see you all. So today we are starting the first day of our jury session of Synthetic Landscape Lab. And today we will present several courses. We will start with the presentations of diploma and pre-diploma students. Then we will have a short break of 1 hour between 12 and 1. And we will continue with prototyping seminar, where students will showcase some physical prototyping that they are working on the curtains with algae. After the lunch break, which will take place from 2:30 till 3:30, we will have a lunch break. And after the lunch break, we will have a design studio too, with the topic of mutualism. And we will close today around 6 o'clock, if we will be good with timing. And now we are glad to start with a presentation of UIBK, if I'm not mistaken, in our calendar. Yeah.
Maybe if you want to just introduce the faculty and external examiner and guest for this morning.
Absolutely. So yeah, today we have a great list of guests and the faculty. First of all, I introduce Dr. Marco Poletto, who is joining us for 2 days for all the sessions, and will be also external reviewer for the diploma projects. We have Rini Tsumoku, who is the partner of Ecologic Studio and also faculty in UCL Bartlett, and co-teaching with us in the Synthetic Landscape Lab and the many courses. Thank you, Rini, also for joining us. We have now, I see, joining us also all our assistants who is working with the prototyping course. Joy, Emiliano, and Claudia will be also with us. And of course, I'm glad to introduce all the faculty, Professor Claudia Paschero, Carvina Enzinger, Teresa Greskova, Marco Poletto is also with us in the faculty of another seminar, and myself. Hi, I'm Maria. Did I forget anybody? I think.
Perfect, thank you. We can start. So who is the first one in the morning?
We are starting with UIBK today. So we go through pre-diploma and then we go to the diploma with Erika.
Perfect. So just for Marco and Irini to comment, the pre-diploma is a passage from the pre-diploma course to the effective diploma, where the student will then develop the thesis. So we have to start a few pre-diploma students, and then Erika, that Marco, you saw the green light, that will present her final defense. Thank you.
I think you need to disable the screen sharing. Yes.
You can share now. You can start.
Can you see it? Okay.
Yes.
So welcome to the presentation of my pre-diploma. The title of my project is For Vesta Fungus. First, I will give a general overview over the alpine region around Innsbruck. Then I will talk about the mycorrhizal process that I will implement in the landscape. Next will be the topic proposal and the most important environmental factors. And in the end, I will show how I will implement the organisms in the landscape and give an outlook on my next steps. The entire alpine region is characterized by its valleys surrounded by steep mountains. It offers a dense network of infrastructure and especially dense network of traffic routes because of the given space of the valleys between the mountains. And if you look at the region on the satellite image, you will also see the forest around the valleys. The forests represent the lungs of our Earth and ensure a climatic stability. Almost 47% of Austria's total land surface is covered with forests. On the left map, the forests around Innsbruck are shown in an area by 40 kilometers, and also the area where the regrowth of the forest already needs to be improved. The dense traffic network has the effect of high car emissions, which have a negative impact on the vegetation around it, which you can see on the right. Regarding the health of a forest, we primarily think of what we see, so the trees. However, the starting point of a long cascade of processes that ultimately provide the forest with nutrients is underground. The significance of Earth's soil is its ability to store carbon and nitrous oxide, and in hosting complex and diverse ecosystems, including thousands of microorganisms. Fungi, which play a determining role in the ecosystem, represent more than 1/5 of these organisms. The mycelium forms a vast and connected network that links the trees through their root system. This tree-fungi relationship, called mycorrhiza, connects the trees in the forest together and forming an underground network, exchanging water, nutrients, and also warning signals. In the natural ecosystem, the underground root system of the fungi, the mycelium, decomposes organic waste and converts it into nutrients and returns them to the organisms. By providing a synthetic overground structure to give the mycelium additional surface to grow on at some chosen locations in Innsbruck, I want to increase the CO2 storing capacity of the mycelium to convert CO2 into highly nutritious, healthy soil. The structure will be completely overgrown over time, and the mycelium will gradually decompose again and reinforce the environment by returning the nutrients and the fungi to the soil. Each life cycle consists of the seeding phase, the growing phase, the expansion phase, and the decomposition phase. Now the process can start all over again or can be repeated at new locations. So the result will be a biodegradable structure that in its very existence represents the natural cycle of ecosystems and the symbiotic relationships in nature. At first, we started by looking at the map of the wider surroundings of Innsbruck. For the implementation of the further project, I will focus on an area about 5 by 7.5 kilometers. And in this area, there is one of the most frequented traffic routes in the airport of Innsbruck. The mycelium network does not only supply the full-grown trees. If an offshoot of a tree is growing, the old tree also supplies the regrowth with sugar solution through the network. So this map shows in which forest areas forest regeneration needs to be improved. A healthier mycelium network increases the supply of young plants and they can survive better. In most of the areas, as you can see, there's already a medium need for improvement, and in some there is already a high need for improvement. Next, I analyzed the forests in the immediate surroundings in terms of their tree species to get conclusions about the tree populations and the predominant tree species. The most common tree species are spruce, beech, and pine. And on this map, the bigger the circles of the forest type, the bigger is the overgrown area of them. And each of those tree species lives in symbiosis with a certain fungus. According to the tree populations at the different sites, the mycelium of the symbiotic species is seeded at the chosen location of the project. So the neighboring forest areas can be supplied with the nutrients in the best possible way. The locations should not only be selected for their proximity to the certain tree species, the density of the traffic and the resulting CO2 emissions are also determined at different locations. To introduce the organisms, I used self-started trials. I started to record the growth structures of the mycelium. For this purpose, I placed a self-made grain spawn with mycelium in a substrate of coffee grounds to get a high contrasting results of the growing pattern. And they will be later used for the design of the overground structures in order to enhance the natural growth behavior of the mycelium. As a second trial, I placed the mycelium on a nutrient medium to analyze the growing behavior. I started to implement the conclusions from the experiments that the mycelium moves through the substrate and does not grow directly as a continuous network by using a growing algorithm on the first chosen site. The first location I choose is between the Inn Valley Highway, one of the most frequented traffic routes, and the Inn River. I analyzed the traffic density at this location by tracking the vehicles and therefore was able to get an indication of the CO2 emissions in this area. And with the inn in the direct surrounding, there will be a necessary humidity at the site for the mycelium to grow. And from this side, I started simulating the growing behavior of the mycelium. And as the fungi not only supply the trees with nutrients, but are also receiving nutrients from the trees, in return, the network will spread increasingly towards the trees. And the trees and the fungi, they need each other as partners to be able to communicate over longer distances. And the analysis of the site regarding the CO2 emissions by traffic will later affect the implementation of the overgrown structure, and depending on how much CO2 should be stored in the mycelium structure. Yeah, thank you for your attention.
Thank you very much, Wiebke, for the presentation. Great progress. I would like to invite everybody to comment. We have few minutes for the comments. Marco, Rini, would you like to jump in?
Nice. It was a really interesting and suggestive project. I like that you started with collecting the data of the satellite that can give you a bigger recognition of the patterns of your satellite. I think what you could improve and make it more actualized, it could be maybe to zoom in and try more local monitoring. For example, you can go to the specific area and start monitoring the elements that can help to the growth of the mycelium that you're using, and also the conditions of the mycelium. So you can see local continuous feedback and exchange with the environment. And you can use this same class quantitative and active module in order to start make the assumptions for the whole area. But generally, it was a really nice one.
Thank you very much.
Mm-hmm. Maybe I want to give a first turn to Marco, Rini, since we don't have that much of time. And then
Sure. No, I was just waiting for you to come up and comment as well. But I can continue on Rini. I was trying to understand exactly what is that you feel it's your main contribution here. where shall I look at if I want to recognize your design contribution, your sensibility as a designer? Where is your design contribution here?
So at this step, I focused on the underground network, but later on the chosen sites, I will implement a structure over the ground, and they will basically be the designing part of the project. So
the underground networks, what are exactly? Like, are we talking about sewage system, electricity? What are the underground networks?
So if you seed the mycelium on a certain location, it will grow under the ground, but I want to give it also a structure over the ground to grow over.
What is that will grow under the ground?
The mycelium.
Where can I see that?
So in this simulation, the reddish part should simulate the mycelium, which is, I can show the previous slide.
But this is a plan.
Yeah, it is.
So how do I see the under the ground? Is it under the ground plan? Is it an under the ground plan?
Yeah, the red part shows what is under the ground, and the white should show the surroundings that you can imagine where the starting point is, where the location is, and where we are in this.
Oh, but sorry, you are a diploma student, right? Or pre-diploma? Okay,
pre-diploma,
so
yes.
you know what a plan is, don't you? You have done it before. Somebody already explained to you that how a plan works, right? When you do a plan, you have to decide at which level the plan works. So in fact, a plan is like an horizontal section, right? So if you're doing an underground plan, then it should show the strata or the layer of soil, right? And there are plenty of geographic description of the layers of soil in the area. And so if your system is to infiltrate those layers, surely enough, the simulation will have to deal with the difference in density, granulometry, composition, biochemistry, and so on, humidity of these layers. So at this point, I mean, everything that you have drawn up until now deals with the satellite view or whatever is on top. So how can you say that your project is about whatever happens in the ground or in the soil, where in fact everything that you have drawn and described up until now is above the ground?
Yeah, because it is about the connection to the forests, and the forests are...
But, do you understand that this is completely...
Yeah, I understand.
Completely kind of invisible in the project. You see, like, I mean, my problem is not so much with what you have described. My problem is that I just feel that you have no connection with what you're doing. Your presentation is like a machine that repeats stuff that has been done already 20 times, to be honest. And I've seen the diagram of the mycelium 20 million times. I heard the story of the mycelium proliferating in the ground 20 million times. I've seen the little Petri experiment 20 million times. I've seen the bubble, description of the satellite image 20 million times. I mean, at some point, you guys need to take some level of ownership or some level of interest in what you do, and begin to dig a little deeper and begin to actually inquiry what is the meaning of what you're doing, and begin to bring up your own interpretation of it, and begin to show passion and interest for that part that you have discovered and that you have created, and it's your own project essentially. And so, I mean, I haven't seen that here at all. And, you know, again, despite this being a whole very competent presentation, I'm not saying that you haven't done the work or that it looks bad and so on. It's very competent, but I find it's very disconnected. Like you sounded like a robot that is repeating a pre-recorded message which basically she doesn't really believe in. It's like a kind of lesson that you are applying because, you know, that's what people do in the lab right now, and that's it. And it's 95% you say it's analysis. So again, I don't understand why a designer would spend the entire term doing analysis, because if I'm a designer, what I want to do is design. Otherwise I go and do engineering. So why again would you spend the entire time doing analysis? And on the other hand, if you do some material experiments, which you have done quite well, again, what is the meaning of them? Like, again, what are they? Another bit of analysis, or is it like you playing the little scientist game? So what is this? Is a mix of pseudo engineering and pseudo scientist? I don't know. I'm just questioning because, and I didn't know, maybe I'm just being a bit harsh here, but maybe this is for everyone. In fact, is that I think we need to move on. You know, we need to take ownership. And, you know, again, like there are very good ingredients here, but I have no idea of what is it that interests you in all of this, the way you presented it. So now what should I do? Suggest you what I think it's good? No, I think you should say, right? So that's you know, that's where I would like to see the project going next, to be honest.
Wiebke, what is your comment or your answer to that?
Many things you mentioned are very good comments. I think the point is that it is still a progress, and especially the design part will be the biggest part of the following diploma. So the first part needed to be getting in contact with all the environmental factors, and of course it began with the analysis regarding the presentation. And I sound like a robot isn't basically because I'm nervous, okay? So I'm very interested in this topic, so it's not a point. Yeah, I think
the question, in my opinion, is how you deal with struggles. And I believe this year entirely virtual actually didn't help in tackling struggles. Because, for example, you deal with mycorrhiza. You never worked with us before. I think you quite diligently, as Marco pointed out, learn a drawing technique, also develop material experimentation. But there is an aspect of, for example, of all the projects we have dealt with that deal with mycorrhiza that I find really problematic, because mycorrhiza in itself is a technique which is underground, which we don't see, and that is in itself considered purely in the engineering realm. So the design implications of these are totally not clear. What I found problematic, or that needs to be understood in this project, is how do we tackle a technique of soil consolidation or transformation that is usually purely part of the remediation and engineering environment, and transform it in a design opportunity that transforms the landscape. There has been other projects actually in the past. I remember the bachelor project of Claudia that will be later with us in the prototyping, that dealt with mycorrhiza and assumed that the landscape would be later eroded. So you have this emerging network of solidify element that you have. But how is this transforming the landscape? How is this entering the realm of design? I think this is something you should, I mean, there should be a struggle there. It is not clear. It cannot be presented as something that, yeah, it flows, because it doesn't flow. It's a really difficult subject to tackle in design, in my opinion. So I think one of the maybe most problematic aspect that Marco comment underline is that if there is a struggle or a question to resolve, we should discuss it, or we should try to point out a tool that enable us to resolve this struggle and actually start designing. At the moment, the drawing, as Marco pointed out, are diligent and diligently evolved, but somehow they avoid conflict. Like the image we see here, we see a network that clash with the existing structure, but there is no conflict that is underlined. It's presented as if this will be okay, as if this is the proposal, but it cannot be on different level. It cannot be because mycorrhiza is underground and we don't see it. It cannot be because we don't know how this structure, if this is the drawing of the structure, actually deal with existing morphology and how we transform it and how it becomes a design. So somehow it's presented as if this is a proposal, but at the same time, it's not resolved. So that is conflictual, in my opinion. Do you understand? Yeah.
Sorry, if I can jump in again. I think as a designer, if you decide to bring and take such a peculiar organism as your subject, then I think you must be doing it on purpose. You must be doing it consciously. It cannot just be like something that happens and then you just go along with it, because it's a very unusual choice. It's not normal. Like, it's not like people normally design and normally don't use mycorrhiza to design, right? So if you do it, you are putting yourself in a unique position to either fail miserably or succeed greatly. But this is not a given. It's up to you. So now the question is, if this is an underground organism, the fact that you choose these as main ingredients, main system of your project, is that because you have interest in exploring the underground world, I suppose, or you want to make a claim that architecture and landscape architecture should not concern itself exclusively with the surface of what we see, but also with the layers of the ground. And that in the layers of the ground, by the way, the city actually is present in many ways and forms through multiple infrastructures that are in fact buried in the ground and that we don't see, but they are very crucial to the way the city functions, and that they are crucial in the recycling of nutrients and the processing of waste and so on. So, I mean, I'm just making an example, but what I'm trying to say is that if you, as a designer, engage with an organism like this, you must be extremely interested in this world that is under there. Otherwise, why would you do it? Otherwise you would do something else, right? So, what kind of worries me slightly about this presentation is that I don't see any intentionality on your side that tells me, oh, actually, she's got something here that she wants to explore, and it's highly original, and she has that intuition, and now she's going to explore it. I cannot see that. So that's where my worry comes from, because it seems like you're taking everything in a way as if it was a given, but I can tell you it's not. It's a highly unusual and original direction, the one you're taking, and I think either you take ownership of that, or it will become increasingly problematic as you move forward. The other thing are the material experiment that you've done, because the material experiment, they can help a lot. And actually they have certain qualities, the material experiments you have done. But again, there was no sign of any kind of intentionality, meaning, what you may be able to do with that material experiment. I mean, would you be able to create little design object, or is the point to try to create little material prototypes or samples for construction, for implementation? I have no idea. I mean, the moment you present it in a way that it could be absolutely anything or nothing, and again, there is no sign that you have that maybe you're just at the beginning of a trajectory, but you have a kind of intuition about where you want to go or the kind of world you want to explore. And again, I think that's quite worrying because, you know, at your level, you know, that sort of intuition, that sort of idea, it should be there. You know, there is a whole world there of designers and material scientists that are working, collaborating, doing, you know, growing product design, growing materials of any kind. So, you know, where do you position those experiments, you know? In which world, in which realm of design your experiments are or will be or maybe or you want them to be, you know. So, you know, this is not going to happen on its own. I mean, needs to be your drive, your curiosity, your knowledge, your desire that brings it up.
It's a super important comment, and I really wanted to give like the guests to speak because we talk with Webke for quite often. So thank you very much for the feedback. I think that we need to move on to the next presentation, and yeah, I would just agree that we really need to see how to find your individual take within the project in the following semesters to bring it to the diploma, to the level of diploma. And I think there is a good technique set it up for drawing, for documenting. There is like from my side, I see there is a great step that we've done. But I absolutely agree with the comments, and thank you very much, Irini and Marco. I don't know if Teresa wants to add something, or Corbinian or any others, or we move on.
Yeah, if we have just a minute, and because I actually always really like the approach to kind of map the information which is actually not visible like in real life, but then also, as Claudia and also Marco were mentioning, for me it becomes interesting when like how does it become visible, or how does it kind of affect the overground landscape or also the urban environment? Like, is it kind of the mycelium? Is it then like stabilizing the ground and therefore in between kind of eroding and therefore kind of changing the morphology of the landscape? Because I think now, like in terms of analysis, I really like this work, to be honest. But now for me, it would be interesting, like I said, like how it's affecting the actual overground environment, or how is it beneficial to apply the mycorrhiza like this, besides having like this beautiful network like in this drawing.
Thank you, Corby. Okay, I think that I would need to be a bad policeman today and push us with timing because we're quite late. Thank you, Webke, for the presentation. I invite Patrice to present next.
Thank you.
Good morning from my side. I called my topic green corridors. I will start with an overview about my topic introduction, then the greenhouse gases, my problems to urban heating, my analysis and my reference project, and then I come into my organism and my design proposal. So in my topic, I want to propose more green into the city in form of a new infrastructure. Because cities are...
Can you go full screen, please?
I'm full screen at the moment. Maybe I'm the wrong side. 1 second.
Yeah, I was.
Now it's better. Sorry, was on the wrong switch. So in my proposal, I would like to bring more green into the city in the form of a new infrastructure, because cities are the major contributors in climate change. 87% of energy is consumed in cities, and over 60% of the greenhouse gases are produced there. The sheer density of people depend on fossil fuels, makes urban population highly vulnerable to the effect of climate change. Less green spaces due to the ground ceiling further aggravates the problem through urban heating. 55% of the world population lives in cities, and more becomes every day, which leads to urbanization. More and more houses are built, infrastructure, roads and others, and as a result, more and more lands are sealed, which leads to less green. This makes the city warmer and warmer because the loss of the cooling function of the green space and the CO2 emission increases. So currently, city produces 60% of the greenhouse gases. Since this is a cycle, the number is continuously increasing. In the background, you can see a map of the carbon footprint of America. Here you can see that most of the emissions come from cities, like for example, on the right side, New York City. So what are greenhouse gases? Greenhouse gases consist of 4 groups: the carbon dioxide, methane, and nitrous oxide, and fluorianted gas. The largest share brings CO2. Carbon dioxide is an odorless gas, which is very important for the life on Earth. But CO2 is also known as a greenhouse gas. Excessive concentration can distribute the natural temperature and regulation in the atmosphere and leads to global warming. CO2 is heavier than air, but is brought into the atmosphere by circulation of the temperature in the air. CO2 is produced by varieties of sources. For example, the most of the part coming from the energy production, then the transportation industry, and the building sector. The top 5 countries which produce the most CO2 are USA, India, China, Japan, and Russia. The rest of the world follows with 42%. The USA with 50% produces CO2 emissions mainly through transportation, energy production, and then follows the industry and the residential sector. When you took a closer look to New York City, most of the CO2 emissions are generated by energy-related emissions from buildings. This is followed by the traffic and the transportation sector. So how can these CO2 emissions reduced? Most of the answer is with more green. But now the problem of urban heating arises. Urban heating means that the sealed surface in the city heat up to the solar radiation on the day and cannot cool down to the lack of greenery as a cooling function. So at the night, the surface radiated the heat and the cities are getting warmer. Due to the sealing of the soil and the growth of the city, the green areas are reduced and emissions are increasing. In the satellite picture, you can see very well that how little green is in the city. In comparison, a temperature map where you can see the sealed surfaces are much warmer than the green areas. In New York City, it's lucky to be surrounded by water, so it says a cooling function. So all in all, due to the sealed surface and a few green areas, the temperature and CO2 emissions increases, which cannot be reduced. And with my work, I want to counter these problems. I would like to bring more green into the city and create some shade and use the public areas such as roads. So I started with my analysis. First, to see where the green space is, which buildings produce the most CO2, and where the traffic is the densest. For the traffic mapping, I use the drop of the caps, where are the most. And then I use the upper area near the Central Park. There's the most CO2 produced, and the traffic is the densest. There's also the highest buildings of New York City, the upper area. Then I broke down the different factors into building heights, emission, green spaces, and traffic. Combined, you can see the highest building generate the most CO2 emissions. Most of the area is sealed and there's a little green space. The traffic in this area is also the largest. On the next one, I tried to connect the green areas with the emissions. That was one of my first ideas. And the same again with another system to lay a kind of a net over the city that connects the green areas with each other. I wanted to focus on the places where the most CO2 emissions are generated, which are why I zoomed once again inside. Here, I have brought a few more factors into play. For example, not only the green areas like parks, but also the trees. These are growth in this area. Also the public square and the wind movement. In summary, you can see the lit green there is in this area, a kind of concrete jungle overlaid with the CO2 emissions. And I also tried to make the connection between the green spaces and the emissions from buildings and traffic in this area. Then I tried to do this in 3D, so you can see the whole thing is 3-dimensional and grew up the building. I wanted to create a level above the street, which grows through the city. So then I'm coming to my reference project. I was looking for a reference project and found the New York Highland by James Conner Field Operations, a project that used an old train track at a height of 7.5 meters in the west of Manhattan. The High Line is 2.3 kilometers long and has converted into a park. The railway lines run between the buildings and is, for me, an amazing project to how to deal with existing constructions. It brings greenery into the city and moves the public realm upwards. Then I'm coming to my organism. This is the head of the High Line. I look for an organism that brings structure and at the same time further function. Here I came up with lichen. A lichen is a symbiosis of fungi and algae. The fungi provides the structure and the algae feeds the fungi by photosynthesis with biomass. So it's a cycle. In detail, lichen consists of different layers. There's the fungi structure, which consists of the cortex, the skin, then the hypaea, the lower cortex, and the rhizomes. And then there's the feeding structure, in which the algae are found. The algae is enclosed and held in the hypaea by filaments. This is followed by the lower cortex and the rhizomes, which are the anchors for the lichen. These rhizomes are helping the lichen to stay on any material. And I wanted to use this symbiosis in my proposal. The fungi mycelium as a structure and the algae as a food resource to grow. So I started an experiment to see how the mycelium behaves in air. I have stretched strings in a small box which act as a base structure. I applied some nutrients to have a medium for the fungi and a small piece of mycelium on it. What I hoped to get out of it was, in the experiment, is a network of mycelium that connects the whole structure with each other. My first experiment failed because there were some other organisms inside, but I want to try this once more. Then, in my mind, I started to computational side simulation of this to create the whole thing on the computer. The lines are the attracting areas, and the swarm grows around it. And then I transferred this to the city. The starting points are the green areas, and the points of attraction are the highest CO2 values and bear the most traffic. For the last step, I zoomed in a little closer in this area in the middle, which brings me to my design proposal. I have adapted the idea of this experiment. The system will sit about 10 meters above the existing trees and above the traffic. The structure will collect the rainwater and channel it through the entire system. The lightweight construction allows the air flies through, so it can filter out the air pollution. The platforms will filter the air, and the whole thing will then be compacted by the mycelium structure on which plants will later grow. The structure is supposed to grow and spread through the city, so it gets a new level of the public space in the concrete jungle and above the traffic. And this is my presentation. Thank you very much. I open for your comments.
Thank you, Patrice, for the presentation. Anybody wants to jump in now?
Yeah, can I just ask if you can go back to the 3D, the only image that is a three-dimensional?
Yeah, sure.
Quasi three-dimensional.
This one.
Exactly. So why is that image so, let's say, non-architectural, or why it omits the buildings in a way?
I tried to use the high maps out of it. I started already to regenerate most of the city in 3D, but I tried to apply some different algorithms on the 3Ds, but it didn't work. So I needed a high map. So I used the high map to regenerate or generate this image.
Yeah, the IMAP I understand, but the problem is that if you work in a context like Manhattan or wherever you are there, obviously you can't avoid engaging with the building massing three-dimensionally because it's so obviously not a 2D condition, right? So, but I think that again, you know, like that's also where your whole discussion can become interesting, because all of a sudden these patterns of growth that we are so used to see in a kind of landscape, in a kind of 2 or 2.5 dimensional landscape, like here they make no sense. They have to climb up. They have to, you know, either rob the buildings or fill up the spaces in between the buildings entirely, or like you gotta come up with something, right, that is new. So in my mind, your gradient fields are interesting, but they are not accurate enough in describing the reality of Manhattan. Like if you are dealing with the urban heat island effect, which is basically what you're trying to deal with, and you know that there are a set of strategies to deal with the urban heat island effect. One is to change the color of the city, like to change the albedo of the city. The other one is to increase the evapotranspiration, which is basically your technique in a way, like increasing living surfaces that are able to essentially transpirate, so they cool down the city through evaporation, like pretty much like sweat does on the human body. And the third technique may be to actually change the overall massing of the city to increase wind circulation and sort of reduce the canyon effect. But I think clearly your choice is on the second. Now, it's a fascinating idea. You could really look at the three-dimensionality, maybe realizing that the gaps in between buildings, could be filled up. In a way, your simulation could be very much taking the massing of the city as a three-dimensional body and really explore what it's like when you apply this model in the three-dimensionality of that. And I think that's probably what this diagram wants to say. Maybe, I don't know. Again, like I think that is the same comment I had before. I wish you told us what this diagram is trying to do, and then we could say, all right, it's a kind of early sketch, early drawing, but there is a clear intentionality. So for me, this is the drawing that saves you a little bit, because at least you show that you are switching on your brain and say, hey, wait a minute, this is really a three-dimensional problem. So I have to go in the third dimension. But again, on the other hand, I'm not entirely sure that you are engaging with a three-dimensional problem clearly enough. Like too much of the presentation is 2D, and there is the three-dimensional model of that area is available. It's pretty accurately scanned. So I think you gotta work with that. There is this model that I have here just next to me that maybe it could be interesting for you. It kind of comes to my mind. I don't know if you can see it, actually. Do you see it?
Yeah, I can see it. It's quite small.
It's a kind of white blocks that are, kind of covered by a kind of climbing network and so on. That maybe kind of reminds me a little bit what you were trying to do. But it's that's maybe where you could be going in a much more clear three-dimensional world, and maybe that will be also your original bit of innovation, to take these notions, these concepts that come from a landscape and ecology, and apply them to the most artificial or the most three-dimensional urban environment that you can think of.
Yeah, that's a really good comment. It's a really good idea.
Yeah, I absolutely agree with the three-dimensionality, because your project is, like, to me, it's really convincing in the plan, like with all the mappings that you did. But you were also mentioning that kind of the CO2 concentration at the lower levels is kind of higher than on the higher levels, if I understood it right. So yep. I think it could be really interesting to kind of work also maybe in a section as well, just to see like what height are we talking about of the structure, like how does it affect the streets below and the pollution on the lower levels and so on. But the overall project is, yeah, quite convincing from the narrative to me.
Thank you.
Yeah, congratulations. Congratulations from me as well. Yeah, I would agree with both Corbina and Marco. I think in the 2D drawings, you have done a really successful connection with the network of the city. So if you try to transfer this in the 3D, so you can keep the context of the city, the grid of the city, and also what I'm missing, I can tell that is also the, for example, the values or the thresholds that you're using. For example, maybe this can help you in the next design. For example, you're mentioning the biomass, you're mentioning the temperature, but you never mention, for example, the biomass kilogram per square meter or the values of the temperature that can help you to correlate with the city information.
Yes, it's a really good idea. Thank you very much.
Yeah, for me, it would be important to be more specific in terms of which type of landscape we are talking about and find an area that would allow you to work on that in a more specific manner. Maybe following on the Irini comment that there could be element of measurement that could be the sort of research area where you could focus on. Of course, you're not at the moment in New York, I guess, so the measurement would need to be relocated on the alpine landscape or wherever you're located at the moment. So that is an issue, but there needs to be an element on innovation, either on the way we define the landscape or in the way we measure the landscape and therefore respond with a design proposal. And the idea of, rather than using weather station data, using local monitoring system, I think that could be something that allows us to do a step forward in the project. But that will mean also probably changing side.
Okay. Yeah, I started already I thought about to measure in Stuttgart the most dense traffic street, and then combine this information and translate it to New York City, but I'm at the moment not quite sure about this.
No, I wouldn't do that. If I would measure Stuttgart, then I will change the site for this.
Okay.
And I would work in Stuttgart, and this is the pre-diploma, set up the drawing technique, set up the narrative, set up the testing. There should be then the setup also of a material system, exactly which landscape are we talking about. It would be nice if it's a landscape that is also multi-species, but in terms of measuring, if we want to go to the local measuring, that I think would be the most interesting part, considering you've always been interested in data, then we need to relocate the site where you are and where you take the measurement. In that sense, probably Stuttgart is a better case study than Innsbruck to some extent. I don't know, you measure local pollution in terms of Innsbruck, but it's a larger urban center, so that probably it's in a way not New York, but it's more related to the type of setup you have at the moment.
Okay.
I absolutely agree. I think it's nice that you have done analysis in the New York City as a sort of case study. I guess you try to take the most extreme example, but it's okay to now choose for the real-time measurement and relocate the site in Stuttgart and keep the New York as a sort of case study where you apply those tools with which you create this drawing. And then what I would be interested with this drawing also is how this drawing changes based on different change in the environment. Does this drawing change if all the parameters stay the same but the wind blow from a different direction? Or does the drawing change between different time of the day, between different year of the day, and how that affects the city? So that we would start to grasp through your drawings the dynamic of the urban scape in some way. Thank you.
Thank you.
Thank you very much, everyone, for the comments, and Patrice for the presentation. So should we move on to the presentation of Joy?
Yes, perfect.
Hi.
Hi.
Hi, my name is Joy. I will present to you today my pre-diploma project. The title is Synthetic Biomass. Humanity has become a dominant force in shaping the face of the Earth. I am interested on how we change the composition of the air in general. I became more critical about the term pure air, and I want to see how we can improve air quality in our cities for human existence. First, I delved into the history of the atmosphere to see which dynamics and compositions were good for our planet and which do not. I created diagrams to better understand the composition of the atmosphere. My first discovery was that without greenhouse gases, the energy balance would be thermal energy from the sun minus delivery in the form of infrared rays, and that would be minus 17 degrees. If we add greenhouse gases, it is plus 14 degrees Celsius. The Earth's primitive atmosphere with inactive sun and strong solar winds did not have any oxygen, consisted of mostly water vapor, carbon dioxide, and sulfur dioxide. There is another process called outgassing. Outgassing from hundreds of active volcanoes today still remains an important planetary function worldwide, as it is part of the closed cycle of carbon dioxide. When the oceans formed nearly 3.5 billion years ago, photosynthesis bacteria began to release oxygen into the water. Analyzing diverse time spans illustrated in millions or billions of years, we can find 5 mass extinctions within the last 500 million years. And due to the loss of biodiversity, we could also put a line on today's state. Climate is not stable when viewed over long time spans. Also, Earth has experienced several back and forth shifts between warm and cold. Still, CO2 levels have been stable since the last mass extinction, and the temperatures we know are about 14 degrees. In the pre-industrial atmosphere, clean, dry air was 99% nitrogen and oxygen. What is remarkable is that only the remaining 1% is affecting weather phenomena and climate. The amount of CO2 was only 0.04%. By 2050, prognosis say that this number will double. The magnitude of such temperature changes is uncertain and depends partly on the quantities of CO2 contributed by human activities in the years ahead. I chose Innsbruck as my site and analyzed it from a macro to an urban scale due to a mathematical drawing set. My macro scale is 30 to 30 kilometers with Innsbruck here. The city is located in the Inn Valley, surrounded by mountain ranges. Populated areas, this is showing the populated area. Sorry, this is showing the populated areas. Because of the temperatures that are located in the valleys. And alpine water flows contribute to the Inn River. I analyzed the city in a 5.5 by 5.5 kilometers square. What the composition of air needs for humans to be safe is to remove greenhouse gases from the atmosphere. In our cities, we can add biomass that performs photosynthesis. To perform photosynthesis, plants need sunlight, carbon dioxide, and water. This image is showing the natural light energy amount on the facades. 71% of the total facade area is below 400 kilowatt per square meter, as one building casts shadows on the other. Around 6.5% has more than 700 kilowatt per square meters light energy. Carbon dioxide is a nutrient for photosynthesis. I generated this map according to connected vehicle data. In general, the air composition is around 400 ppm CO2, but can be significantly higher depending on location and time. Then I estimated the green areas where there is 0%, the area is built. Then it goes up to urban parks or surrounding forests. This can work as an exchange with my design, as these areas provide moisture for growth. Now I want to show you two urban opposite visions that I got really inspired by. One is from the book A World Without Us from Alan Weisman, where the author asks us to envision our Earth without us, and everything we build vanishes. Another vision is from a research group, Terraform One. They prognose a self-sufficient megacity covered in vertical gardens and urban farms. I see potential of non-vascular plants in our cities. Algae is an efficient CO2 absorber and mosses attracts dust. Sorry, the photo in the background I took in Japan. They embrace moss in landscape design to create calmness for our eyes and for our ears. I started by measuring photosynthesis from algae. I used spectroscopy sensor, where we insert the sensor in a box and can see the flux. I started with around 400 ppm CO2, and from these two diagrams, we can see that photosynthesis rate is higher during the daytime. Next time, I would like to do the same for mosses and analyze the dust absorbing efficiency of various species. Ideal temperatures of mosses are from 15 to 25 degrees Celsius, which is significantly lower than vascular plants. Tolerance limits are narrowed to -30 to 45 degrees Celsius, which could work for many cities. For my facade system, I choose a building in Innsbruck. In Wilton, that is oriented 259 degrees, so to the west. The solar energy is 130 to 606 kilowatt per hour. I choose a basic historicism building as it is the typical facade for this city. Here we see solar energy in colors and in numbers, and we can see that the building in front of it casts shadows on the lower parts. I am interested by bio-inspired fault finding. Branching system is a water transportation system. I did a simulation of this to get my base geometry. Ecologic Studio 2D printed glass in collaboration with Swarovski. This could allow me to have a glass pipe system, a bioreactor for algae, that is collecting rainwater as it is connected to the roof gutter. Another organism that I'm inspired by are lichens. Most lichens are made up of several layers. These fissure layers provide shading and evaporation protection. This could be a system for the moss to grow in the 3D print that is inspired by lichens. These modules could partly cover the glass pipes that release water in a controlled manner. I found a growlay filament. It sucks up water up to 15 centimeters, which would be perfect for moisture, and seeds can get caught in it and grow. To summarize, my materials are glass, organic filament, moss, and algae. What I enjoyed most during the process was to work with the sensors. I want to further analyze plant behavior for design optimizations. Also, we can track how humans would react to the facade system. Then for the final exhibition, I would like to have a small prototype for ideal algae and moss growth. Thank you.
Thank you, Joy. I invite everyone to comment.
Okay, well done. I think this is a really nice project. I like that all your research and your analysis on the air quality index or on the microorganism, you try to support it with the values that you're finding. Okay, I think something that you could improve is to continue with your experiment, the biological experiment, and try to monitor by yourself so you can see how these two microorganisms react, and what is the absorption of the urban pollutants that you want to show. And also, for example, in the more zoom-in scale that you're trying to simulate this facade, I think maybe you can correlate more the radiation values that you are finding. So how you distribute this design on the facade based on that, because I think now they're not that related.
Yeah, thank you.
Also, maybe you can also start monitoring in 3 scales. You can start seeing in a bigger scale based on weather station, then in a smaller scale with local monitors, and then to monitor also the microorganism and correlate these 3 values so you can evolve your design more.
Yeah, that sounds super interesting. Thank you.
Yeah, I absolutely agree with Irene's comments, because there's like a lot of research and analysis about different like radiation values and pollution values and so on. It's just still a bit hard to see like how it relates directly to the design, because you're researching in mosses and algae and lichens, and maybe these different values that you get from your analysis could be the base of or the base knowledge of how you're going to distribute, or where you're going to distribute the algae, how you're going to distribute it, and the same for the mosses and so on. So I think if this relationship between the analysis and the design itself becomes more clear, I think then it can be a really nice project.
I absolutely agree with Corbini, and this was a little bit of a mystery for me from the presentation, which you end by wanting to design a prototype and showing us this picture, but I'm not really completely sure where this picture or drawing comes from, and whether your analysis go hand in hand with the design of the prototype, or there is another set of data entering your project later from which you start understanding your application in the city, because you also map the city of Innsbruck as itself. So I think as Irene was already saying, there is a little bit of jumping between different scales, which is actually good, and your project can benefit from it. And you might start working parallelly between the city scale, some kind of a local scale like the one we see now, and the micro scale of the interaction of the different species to their environment, or even to a human being.
Yeah, thank you very much for the comments. Every time when I'm thinking about the design of the facade system, and I question, how do we map the facade? How do we treat the information from the facade? Do we, because I think now that our proposal is not related very much with the analysis that you have been doing previously. And I think all the layers that you are doing, they're in a very good resolution and quality, and all the mappings. But then how do we relate all the different scales? And how do we start mapping the facade, which is information from the facade that you want to bring to your design proposal? And how can we reach the higher resolution of this tree system that you are proposing? Is it a tree system actually, or like, but at least the higher res of this branching is needed, but how do we drive it? Now, what is the input for kind of circulation within the structure? Is it exactly the right scale you're setting up? So these are the questions that I would target. But yeah, like how do we design? What is the method for designing the facade system? I would start thinking on that maybe.
Mhm.
And first of all, we were talking about this with you. I would start seeing how do we bring the facade itself? How do we maybe treat the facade same as you were treating the landscape and then the city? And now when you are coming to the scale of the building, we need to give the same
attention. Maria, sorry, can you just ask why are we talking about facades, by the way? Like, how did we came about?
Yeah, I didn't understand this either.
Why are we talking about facades? The worst and most boring topic in the history of architecture. I mean, just to know.
To make the most boring topic more interesting.
Okay, but like,
No.
how do you make sure that this is not extremely naive? I mean, let's say facade engineering, it's dominated by engineering companies, which essentially define everything from beginning to end. All the specifications, the contractors, etc., except for a very, very few buildings, which normally cater for, you know, like 0.1%, which are buildings where everything is customized and designed ad hoc. And this, in this case, of course, this building typically have even more embodied energy than other buildings because they are kind of virtuoso interpretation. In some cases, they are interesting. But again, if the objective is to have an impact at the global scale, like you mentioned at the beginning, obviously they won't. Then, of course, you are looking in the specific case at historical buildings. Now, you know, that is a very, very specific topic. And again, I completely, you know, if the idea is to, you know, retrofit all historical buildings with a new facade, I think at this level we would need a very detailed and much more convincing argument of why would you do that? Like, what would you essentially retrofit buildings that by definition are already quite good, and that in, you know, environmentally, and that also are very much connected to an historical apparatus of architecture, of symbolisms, and so on, and, you know, which demands a kind of a yeah, argument on its own. That's my point. I mean, why, you know, I think that the whole argumentation that brings us to this point is completely lacking. And so that's one comment. The other comment is that in the whole presentation is not clear what is the topic, because you go from CO2 to air quality as if they were the same thing, but actually they're not. Like, you know, the urban realm is filled up with particles and pollutants that are of a very different kind. CO2, it's not even a pollutant per se, although it is a greenhouse gas. So again, what is the topic here? Is it, you know, greenhouse gas? Is it carbon neutrality? Is it a carbon cycle? Or it's air quality, air pollution, respiratory health, and so on? I think you should make that very clear, because obviously that has a big implication in terms of the scale and the kind of design solution you can come up with. If we are looking at, let's say, air quality where people are and when they are breathing, it's one thing. If we're talking about, you know, carbon balance or carbon absorption at the global scale, it's a completely different thing. And so again, the scale of the solution also will be different. You wouldn't probably want to 3D print a glass facade to try to offset CO2 on a global scale. So, you know, there are a lot of interesting elements here, but once again, I think there is surprisingly no design sensibility in kind of bringing them together. And I say surprisingly because I remember very well your project, you know, a couple of years ago, where you showed design talent and design sensibility, and I wish that we could see that here as well. And I'm kind of a little bit disappointed that seems like you have decided design sensibility doesn't matter anymore because we have the carbon problem. And I would argue that is exactly the opposite, that the only way to try and tackle the carbon problem is a true design sensibility. And you know, and I wish that would, you know, come forward more clearly.
Mm-hmm.
Can you just go back to the facade 1 second, like your case study building? So what brought you to this building, for this particular building?
It's located in a housing area, and it is, as I said, a historical building, a historicism building, and this is just a typical facade in Innsbruck, because most of the city was built during that time in this style. So it would be good to have this prototype that works for like many buildings. So I chose just a type of building that is mostly here. And I chose a very basic one, and it is all.
So the idea is that everything. Yeah. Okay. I mean, again, is the question carbon, or is the question air pollution, or what is the we're looking at, or you know, what is wrong with this building in the first place? I mean, why would we do anything to it?
No, there's nothing wrong with the building, but it's just not enough biomass in the city to produce to absorb carbon. So still, the project is about carbon.
There's already something growing on it. Shall we just continue growing that stuff that is growing on it already, or what? Maybe everything starts from, again, the case studies that you have brought forward, which are also extremely superficial. You know, if you go back a couple of more slides. Yeah, maybe go back. Exactly. Okay, this is now the first one. The first one is it's a drawing, but it's connected to a kind of narrative, no, like a fictional narrative, right?
Mm-hmm.
Exactly. So maybe if there is anything interesting to your own narrative and that you extrapolated from the book, then maybe it would be good to, yeah, to point it out, to bring it out, so that we can get inspired from it. Because otherwise, yeah, I don't know. I mean, like if I take it literally, then I'm thinking that your project is about exploring Innsbruck after, you know, humans are disappeared and Innsbruck has been, you know, reconquered by the alpine ecosystems. But then, you know, the rest of your presentation doesn't seem to suggest that is your intention to explore that. So again, I'm left a little bit yeah, puzzled about what is the point of having this reference here. And then if you go to the next one, and you know, obviously we know Mitch personally, and he's a super guy. But this is probably one of the ugliest drawing I've ever seen in my life in terms of urban regeneration. And again, somebody like you that has always shown and demonstrated a really good eye for creating beautiful, crafting beautiful work. The choice, the deliberate choice to put such an ugly piece of work in the presentation is yeah, it's I don't know what it means. So what he wants to suggest, especially given the fact that Terraform One has in the years developed several visions and prototypes, of course, many prototypes that were, if not elegant from the point of view of the design resolution, but certainly very, very exciting and interesting in terms of their inventiveness and in terms of pursuing them all the way to one-to-one prototyping, construction, and so on. So, I mean, why this? You know, I don't know. There is a lot of things that I don't quite, I'm not quite able to kind of recognize, and maybe you could reflect upon, and maybe even look back at some of your older work and where you seem to value design more, and where I think that there was a clear agenda and sensibility in terms of your design intention.
Yeah, you're right. I agree with the comment.
Thanks.
It doesn't matter if I'm right or wrong. It would be interesting to hear your thoughts.
Yeah. What are your comments, Joy?
The comment is that I really need to have more design, like sensibility, like you said, but I'm looking forward to do it next term and to put also more time into the project.
Are you in a period of your life where you think that where you're not so interested in design, or what's going on? I mean, like, maybe you can talk about this. It's not like a question of saying right or wrong. You know, really, I mean, what is your feeling about this? Like, what, maybe you have other priorities, or you think that there are other priorities, or how do you see this?
No, I do have this sensibility, but I still need to like show it more in my drawings. So I have a lot of things in my head going on about the project, but just need to show it more.
That's true, but on the other hand, I agree with Marco that let's go on another image now. That there is an aspect that is problematic in a way, and we need to try and understand how we tackle it. Maybe off the jury, but we need to understand how we tackle it. Because, for example, you work with us and with the lab for more time, and you know the lab well. You also have usually a good visual language that, as Marco pointed out, got a little bit lost here. I think the project, different from the previous two, has far less clear visual language, which is surprising, as some point of in-depth research and originality that I think are emerging, which I think is good. On the other hand, is lacking a lot of consistency. So this is something I think we need to discuss, probably off the jury, but to understand how we tackle that, because it's really lacking a lot of consistency. For example, we never use, as you know, case studies as full page. All case studies can have something relevant, but you know they are not the product of your work. They are case studies, and I'm not going to evaluate, you know, Joachim render if it's the best one he did or not. But on the other hand, it's not something that usually in a presentation we have, you know, for front. We organize diagram, and the case studies become research. So they are cataloged according to what is interested from data studies or from another case studies, but they are not presented in a pre-diploma full page. The research need to be always going in parallel with the development of drawing. And at the moment, there is really almost really small amount of drawing in the presentation. There are these visual at the, towards the end of the presentation that give an idea of a possible morphology, but as you know, we usually relate, you know, path to points and points to other elements, so they are not consistent drawing of what the proposal would be or what the setup would be. So I'm not gonna go in detail to that because I don't want to be necessarily negative about the project, but there are, while in terms of research, I think there are a lot of elements that I think are really relevant and original. And there is a brief that is very much pertinent for the lab. I think the overall presentation is lacking a lot of consistency. So that's something that we really need to tackle, because I think your project and you as a student have much more potential than this. So we can, as Marco said, if you're busy in something else, you know, settle for, decide to settle for a lower standard, I don't know, but that would be really a pity, and it's not the premises through which we started the thesis. What do you think?
Yeah, I agree with all the comments. So.
Thank you. Are there other comments? Otherwise, maybe we can move on.
Yeah, I think we need to move on. Thank you very much for the comments, and Joy, thank you for the presentation. We go for the presentation of our diploma students. Erika, we invite you to present. So now we are moving from pre-diploma to diploma.
Thank you. Hello, everybody. Welcome to my presentation of my diploma project. My name is Erika Molina, and the project is called Symbiotic Landscape. Symbiotic Landscape is a reflection about how to work with nature in an integrated way, creating a symbiosis where the architecture can benefit the resources of the territory, and at the same time, the architecture can generate benefits to the same territory it occupies. In the current area, human activities have begun to cause biological and geophysical changes on a global scale. Thus, their impact on ecosystem is comparable to any geological agent. Hence, we are in the Anthropocene, and there is the need to take action to protect our nature and benefits from it on all new architecture project proposals. This work analyzes the territory, considering it is a performative material. The latter entails an approach that looks at the territory from its hydrodynamic behavior and its water path system, showing a particular language for each topography based on optimization and efficiency criteria. In order to understand better these processes, this research begins with the simulation of a number of landscape options. Once these processes are understood, it is possible to manipulate the landscape to achieve certain pattern of hydrological behavior. The project is located in Kutai in the Stubaital Alps in Tyrol. Kutai is a self-organizing territory in mountainous conditions. Kutai presents itself as an opportunity to study and offer a futuristic alternative, a new way of living with the territory while maintaining the ecological balance, thanks to the new technologies. A reflection is established on how the path and flow of water are powerful agents of erosion, capable of changing and modeling landscapes. Water is an important force in the formation of the landscape. We can also include in this classification the territory's occupation by human beings, if they are products of the self-organization processes. The design process explores interaction of the software with the territory, simulating future erosive processes. The aim of the proposal is a renaturalization of the territory, with urban morphologies that arise from itself. It is understood not as a background, but as the project itself. The software allows data management and visualization, as well as data analysis and manipulation. The interaction between plants with different information not only gives a new morphological perspective, but also allows to quantify the information. The software maps the territory, obtains data, and juxtaposes them to obtain even more information, a data landscape. Indeed, the territory is interpreted not only through what is seen, but also through what is known about it. An interesting aspect is to analyze the flow accumulation algorithm that allows not only to identify the location of area prone to water accumulation, but also to quantify the amount or volume of water accumulated. This volume can be interpreted and expressed in spatial terms. The original topography is manipulated and a new morphology emerges on localized water flow area, responding to expression as useful, optimal, effective, or economical proposed according to the definition of fry of past system. A clear boundary condition can be distinguished in the south along of main route. Conversely, the north displays a more diluted or blurred boundary condition between the project and the mountainside. In this way, the project opens up towards the natural space. This organization allows the merge of different areas which create micro conditions. Some areas creating optimal conditions for aquaponic agriculture program. Other areas more prone to water accumulation, suitable for a health and wellness use linked to tourism. Finally, we've created a synthetic landscape integrating into the environment that emerged from the logic of past systems. And the design recreates a morphology capable of infiltrating and retaining as much water as possible in the area. The proposed architecture project presents a biological system based on algae panels, capable of transforming the architecture into a living system and interacting with the environment. In order to design the architecture aesthetic, solar radiation has been used as a design parameter. The areas of maximum radiation will be most suitable to achieve efficient photosynthesis, with the microalgae providing energy to the building. The aesthetic obtained with this system is in accordance with the maximum efficiency of algae production. On the facade, we can see a differentiated area that will contain the microalgae too, where photosynthesis will take place. The project to the topography and the facilities are characterized by an open structure that allow adaptation and flexibility according to the needs to the program. The building is capable of generating its own energy. As a matter of fact, the project combines the hybridization of programs, facilities, and nature, proposing the coexistence of space destined to leisure as well as work, research, and agriculture. The dialectic between the natural and the artificial continues inside the building, with reactor tubes miming the branch structure of tree, taking a reference Hortus by Ecology Studio. Each panel is connected according to the shortened distance. The bioalgae liquid is transported for each panel until it reaches each tree trunk. The tree structure is located at the intersection between architecture programs. The morphology of each tree depends on the location, number of panels, and therefore the amount of liquids to be transported. The design is approaching the microscale in a process like the one already described. The process continues continuing reconfiguring of outdoor spaces and texturing the various parts of the project. The final result follows an aesthetic that is as natural as possible, creating a new synthetic reality that's a very structure and living system, imitating a biosynthetic gardening. That is all. Thank you for your attention.
Do you have the video? Did you? Thank you. If you don't have the video, we can open to comment. Thank you.
Thank you, Erica. I'm happy to see that you have added several elements from last time to complete your proposal. I think also the narrative, the way you have explained the project is flowing quite nicely. So in that sense, it makes sense it makes sense in relationship to the drawings. There is a much clearer correspondence compared to last time. Also, the way the landscape is becoming part of the proposal, and it is taken into account. It is interesting. I still have some reservation, I have to say, in terms of the way the architecture itself is resolved, although I understand better now the space, the way it works, and the internal organization. I'm still left a little bit wondering, you know, the kind of the claims you make, in a sense, versus the actual formal and technological arrangement of the building. I think there is still a certain difficulties on my side to reconcile the two, but I think that at the same time there is a progress, and there is a certain conclusion to it, which I appreciate. So in that sense, I'm happy to see that after the last time.
Thank you.
Yeah, I also need to say that the project...
Congratulations from me. I wanted to add that, for example, in the scale that you're working and in the scale that you're discussing, for example, the materials, what I'm missing is another layer of analysis, why you're choosing these materials, how these affect the microorganism. I think you should start looking in more detailed information and monitoring or analysis, because we are treating this scale as it was like a bigger scale, like a more zoom out landscape scale. So for me, you should add this extra layer of analysis, focusing on the microorganisms and the materiality that you're using.
I absolutely connect to the comment of Erini. I was wondering during the presentation whether the white surface of the landscape will at some point disappear and be replaced by, you know, the dense information that is encoded in the landscape, that is dynamic and perform in certain way, and is full of microorganisms and organisms that, you know, are shaping the performance of that landscape. However, congratulations, I enjoyed the wetness analysis that you were doing. And I will leave the comment to Maria, because I saw that she was trying to comment before, so maybe.
Yeah, there's a bit of a delay probably with the sound. Yeah, no, I wanted just to say that I'm also happy to see a great progress in the project. I think that we moved from quite a heavy industrial proposal to the more beautiful project, and more elegant elaboration on the topography. And I think that you showcase some great techniques with erosion, and it brought you to like a good final step that you are now. I'm not sure if the section really correlates like what you were showing with the final surface, but I think overall it's quite coherent, the presentation, and there's a great step that we've done in the work. So thank you very much, Erika, for your presentation and for the work overall.
Thank you to you. Thank you.
Okay, do we have any other comments for Erika?
No, just thank you, Erika, for integrating more of the landscape aspect as discussed in the green light and in the last tutorial. And if there are no other comments, I think we can take a short break and then restart with the prototyping course.
Super. Thank you all for the morning session. We will we will come back at well, we are actually quite good with timing. So as planned, we will come back at 1 o'clock to the prototype course.
Perfect. See you in 1 hour. Thank you. Bye.
Bye.